All right. Good morning, everybody. I hope you guys are doing all right. I wanted to, first of all, let y'all know that I'm thinking kind of strongly about pushing the test back until either the Tuesday or the Thursday after spring break. Does anyone have a thought on that? An opinion of that? Yes, please. Okay, well that's pretty clear. Those are good. Those are pretty clear and compelling thoughts there. So what I think I'm going to do is post a survey on Canvas and just get everyone's vote on Tuesday or Thursday. And I just want to give you guys a little bit more time to work on some of these practice problems and view all the videos. And, you know, I need to get myself straightened out and make sure that you have all the content that you need. So that's, yeah, I'll expect a survey a little bit later today. Then I do need to get, I believe it's I just posted the Thursday homework problems video on Canvas. I'm going to be posting this one afterwards. I need to get, I believe, Tuesday and Wednesday from last week as well, just posted to the Canvas page. So I will be getting that up to date a little bit later today. At any rate, I wanted to go ahead and get started. And what I wanted to focus on today was specifically question number, where is it? Yeah, question number 27 was the one that I wanted to start with. Because this is a little bit of a tricky question, and it presents something that kind of throws people for a loop from time to time. Just a second, let me get my stuff out of my way. Okay, so question number 27 reads, how many moles of NaCl, if mixed with excess Pb2 plus ions in solution, would be needed to form 47 grams of PbCl2? That's the question that I have. Yours is probably going to be a little bit different with a different mass of PbCl2. But that's what I've got. Okay, so the question is basically how much NaCl will be needed to make 47.0 grams of PbCl2. Oh, that's L2. There we go. So effectively what you've got here is you've got a reaction, and one of your products is PbCl2. Now, one thing that I think is a good exercise to do is think about what is that compound. PbCl2 is lead chloride. Okay. Now, that lead chloride is coming from NaCl, or sodium chloride, plus Pb2 plus ions, because the question says there's excess Pb2 plus ions in that solution. Now, this is a little bit tricky, but does this ask us, or does this really say anything about the compound that Pb2 plus ions are coming from? Does it say, oh, well, it's PbF2? It doesn't. Now, a fair question is, well, does that matter? And to answer that question, no, it does not. Directly to answer that question, no, it does not. Because what we need to do, and all that we need to do, is we need to balance the equation as we have it right here. So can we do that? Well, we can see right now that the Cl is not balanced. How would we balance that? Well, there we go. That would be balanced simply by putting a 2 coefficient in front of that. Now, what that tells us is we have a reaction taking place, an ionic interaction or ionic reaction with lead ions and sodium chloride ions, and PbCl2 is formed. So that is taking place in a 1 to 2 molar ratio. So every 1 mole of Pb2 plus, you have 2 moles of NaCl. And from that, you're going to produce 1 mole of PbCl2. So the question tells us that we have 47.0 grams of PbCl2, Cl2, that is produced. Now, what else do we know? Well, we know that we have a balanced chemical reaction, but what we want to know as well is the number of moles of NaCl. We also know that we have excess lead ions. Sit. There you go. So we have excess lead ions. We have and this is the case anytime you see an excess limiting reactant problem, or a problem where there is an excess reagent and a limiting reagent. If one thing is in excess, the other is limiting. And that goes back to that cheese sandwich example. Well, if you have, here we have 6,000 pieces of bread and we have 2 pieces of cheese. So the cheese is the limiting reactant. So the way that we want to approach this is we want to say we have a product that we know something about, and we have a reactant that we want to know something about. So what I'm going to do is I'm going to set this up as 47.0 grams of PbCl2. We have 47 grams of lead chloride. Okay. Now, the first thing that we need to do is we need to convert this into moles. So how do we do that? Well, we use the periodic table, and the periodic table tells us that the molar mass of lead is 207.2 grams. The molar mass of chlorine is 35.45, but there are 2 of them. So I'm going to say 207.2 plus 35.45 plus 35.45, and I get a total mass of 278.1 grams of PbCl2. That is the mass of 1 mole of PbCl2. Okay. Now, well, arguably, now that I have this converted to moles of lead chloride, well, now I can look back at my balanced chemical reaction, which was basically the first part of the question, or the first part that we had to kind of figure out. And I can say that for every 1 mole of PbCl2 that is produced, how many moles of NaCl are going to be needed? Well, 2 moles of NaCl are going to be needed. Now, this question asks us specifically, well, how many moles of NaCl are required? And the way that I have this set up, I started with my mass of lead chloride. I converted my mass of lead chloride into moles of lead chloride. And then I converted my moles of lead chloride to moles of NaCl. So right now, I can set that equal, and now I say 47 times 2 divided by 278.1. And I get 0.338 moles of NaCl. Does that make sense? Does anyone have any questions about that? I know that one challenging aspect of this problem is you're kind of bombarded with seemingly not a lot of information. But what you need to do for this sort of problem is look at, well, what's my product and what are my reactants? Well, I'm told that my reactants are NaCl, and NaCl is reacting with Pb2+. Now, do I need to know anything about that ionic compound that Pb2+ is associated with? I really don't, because think about this as, if you remember, whenever I was talking about those metathesis reactions, that I use the model of AX plus BY yields AY plus BX. Well, effectively what we have here is we've got A, and I'm going to say A plus BY yields AY plus B plus. I don't need to worry about know what the identity of that X was, because I'm still able to solve the problem, because I can still come up with a molar ratio of these two substances to one another. Now, it'd be a more difficult problem if I didn't have the charge on that lead ion, but that's what we got. So if you look at this problem, do you think that you could go to figure out the mass of NaCl that's generated? Yeah, just take it one step further. Look at the periodic table, determine what the molar mass of NaCl is, and boom, there you go. All right, does anyone have any questions? All right, well, if there aren't any other questions, what I'm going to do is I'm going to go ahead and stop, and then tomorrow I'll be on with some more practice problems. We'll be talking about concentrations and mixing different solutions of different concentrations and doing a precipitation reaction. But go ahead and look for a email, or no, a survey on Canvas as to whether or not you want the exam moved to Tuesday after spring break or Thursday after spring break. If you got here just a little bit late, that I shared with everyone that I was planning on changing the exam to be after spring break rather than right before. So I'm going to do a survey Tuesday or Thursday after spring break, or yeah, and just vote. Do you want it on Tuesday or Thursday? All right, everybody. I hope you all have a great afternoon, and yeah, see ya.